Hi, it's time for another math. Easy solution here to discuss the derivative as a function and basically look at graphing the derivative. So recall from my earlier videos on definition derivative, etc. Basically, the definition derivative says the derivative is equal to, or f prime of x is equal to limit as h approaches 0 of f of x plus h minus fx all divided by h. And this one in my earlier videos I showed that this is basically the slope or of the tangent line to any point, or the basically instantaneous rate of change. And now, so basically I'm going to go over how to graph this if you were given a function like, so if we look at this function right here, just a random function, call us y equals f of x. Now if we were to draw the derivative, well, remember, this is just, the derivative is just a slope at any point. So the best way to draw it, if we were to draw it, let's say on this axis right here, is to find the zeros, or when the slope is 0. Because as you can see in this graph, you're going down like this, and all of a sudden you have a point here where if you were to draw the tangent line, it would be just a straight line. And as you can see, this is the rise of a run, etc. This point here, the derivative y prime is equal to 0. So if you were to draw the derivative, this point here, if you draw it all the way down here, it would just be at this point 0, and same with this one right here, this local max. So we could draw this one as well there, and over here same thing. So if we drag this down, it's going to be somewhere here, so it's going to be a 0, and also somewhere here is a 0 right here. So we've got 3 points. And now if you're to graph, well, from the left side of the 0, and in this case here, as you can see, you are getting smaller and smaller, or if you were to draw a tangent line here, it's going to be, well, negative, because the tangent line is going to be rise over run, and since you are basically, rise is going to be negative here, negative r, and run is always going to be positive here to the right. So you're going to have a negative slope, and it's going to be, well, it's going to get smaller and smaller towards the 0, so you will actually have something like this, something like this here. So it's getting smaller and smaller, or less negative. This is a high negative because the slope is higher, and now it's approaching this 0. So something like that. And now at this point, well, if you were to draw from this 0 to this 0, how it looks like, as you can see in this case, now you have a slope going upwards right now, or something like this. So now your rise of a run is going to be positive, and at this point here, well, it's changing pretty quickly here. Now it's going to be a bit constant, kind of, so then this is like a constant maximum slope, and all of a sudden it's gradually going back to 0. So you should have something like where this maximum slope is at a high point, so something like this. And then it's basically, it's going up to it, then it's kind of steady, constant, then it goes back down to this value right here. And now graphing from this 0 to 0 is exactly the same thing as we did over here, where we had a maximum. But now in this case, since you are going downwards right now, the maximum should be somewhere around this point here, because it's really steep. But again, it's negative right here. So the rise of a run is going to be, well, rise, negative, rise is a positive run here. So you're going to be going really negative, and as you see, it gradually changes from the 0, so it's becoming negative, and then really negative at this slope, and then again going gradually back to this point. So we could graph a minimum somewhere around here, and as you can see in this point, it's going like this. So we were to draw it gradually, so there's a maximum negative slope, and now it's going back up to the 0, and the 0 is where basically now you're changing to a positive slope right here. And then it goes up somewhere like this, and then at this point here, you basically have, well, at this point there's a big change in the slope. This one is going from small to big, and all of a sudden it isn't changing too much. So if you were to graph it out, it would be something like, well, right now you're increasing quickly, and then it's actually leveling off. So this just means the slope is high, but it's not getting higher and higher. It's going to be just relatively constant right here. So it's slowly, gradually looking like that. And this is our y equals to the derivative f prime of x right here. So that's how you kind of get the feel of drawing it like this. I've had other videos where I would draw functions, and you can see that in the video links below. Yeah, and that's basically all for today. Hopefully you learned from this video, and remember you can also download these notes in a Dropbox link below, and yeah, stay tuned for another math easy solution.